hello Algebra 1, another crick mortar production video. We're going to have a lot less of these though pretty soon. We should have a new calendar. It says May 15th. Today's the 18th. We're doing this quadratic formula review or intro. It's going to be a little different. We're just going to have one worksheet. So you're going to be taking notes and then doing your own work. So like I'll do 1, and then you're going to do 2, then I'll do 3, and you're going to do 4. So you're going to be doing the even ones. I'm going to do the odd ones. Okay, so here we go. So recall the zero product rule, and this was back in Unit 8. What was the zero product rule, or law? Maybe we call it the law. Well, we got a factor. We've been doing that, right? So we're going to factor this. We're going to say, all right, what multiplies and gives me 14, and at the same time adds up and gives me 5. Well, there's not a lot of factors of 14, so I think we could all figure out it's going to be 7 times 2. 7 times 2 is 14, and negative 7, positive 2. That gives me 5 in the middle, right? If you did the outer would be 2x. And you did the inner, you get negative 7x, and that adds up to negative 5x. That's what we want in the middle. All right, but now we're going to go further. We're not just going to factor, we're going to split it up. And we're going to say, all right, x minus 7 is 0, or maybe x plus 2 is equal to 0, because something times something equals 0. That means one of those things is 0. All right, so now I'm going to solve both of these. Over here I'm going to add 7. So my solution is 7. And over here I'm going to take away 2. So my other solution is negative 2. So I get 2 solutions for quadratics. If it's squared, you're going to get 2 solutions. All right. Well, I go to a little tougher one here. Why is this tougher? Well, first of all, it's not equal to 0. I can't use the zero product rule unless it's equal to 0. So I'm going to move that 35 over. I'm going to add 35 to both sides. So 2x squared minus 19x plus 35 equals 0. And this is going to be a little tougher to unfoil. All right, unfoil we call this. So what gives me 2? Not a whole lot. 2 times 1. 2 times 1 is the only way I'm going to get 2. All right. What gives me 35? I think most people would try 7 and 5. But you got to be careful here. So let's say I try the 7 and the 5. I'm doing it in pencil, so I can erase. What's my outer? My outer is 10. What's my inner? 7. I can get 17. I can't get 19. I could add those up and get 17, but I can't get 19. Did I fail? Not really. What I got to do now is try something else. And that's why students struggle with this. So maybe put the 5 here, the 7 there. What's my outer now? Well, my outer is 14x. My inner is 5x. And I could add those up and get 19. Now I want to get negative 19. So I need them both to be negative. Why? Well, if they're both negative, they'll add up to negative 19. And then last times last is positive 35. So this was tougher to unfoil. All right, but I'm still going to use the zero product law. I'm going to split this up, and I'm going to get my 2 answers. 2x minus 5 equals 0, or x minus 7 equals 0. And then I'm going to add 5. Run out of room here. And then divide by 2. So hopefully you can see that. I'll put it over here. X equals 5 halves. You could change it to 2.5 if you want. Over here we're just going to add 7. So if I put 7 back in the original equation, it'd be true. If I put 5 halves back in the original equation, it would be true. So I found the solutions. All right, now I did number 1. You're going to do number 2. You might want to pause the video and do it right now. And you're going to hand all these notes in. You're going to show this, and you're also going to show this. So if you're doing it on a separate sheet of paper, you should copy this down, number 1, and then you're going to do number 2 on your own. So I'm moving on now. I'm going to number 3. Another way you might have worded this is basically the same thing. The roots of a quadratic, also in Unit 8. So now it looks a little different. It says y equals. But I want to find the roots. What does that mean? You set it equal to 0. So just let y be 0. Okay. What kind of factoring am I going to do here? Now, you might recognize this as a DOPS, difference of perfect squares, but what it really is a GCF. 4 goes into 4, and 4 goes into 100. I'm going to take that 4 out of there. What do I get? x squared minus 25. That's adopts difference of perfect squares. So what do I get now? X plus 5, and one of them is going to be x minus 5. All right, I'm going to split this up now. I'll split it up into 3 parts just to show you. 0 equals 4. No, 0 never equals 4. That's impossible. X plus 5 or x minus 5. They could equal 0 though, because I got an x. If I take away 5 from both sides, if I add 5 to both sides. So what are the solutions? Negative 5 and 5. There's no 3 solutions, just 2 solutions. Quadratics have 2 solutions. What about that 4? It doesn't affect the solutions. All right, come over here. Hopefully you recognize this. What is that? It's not a trinomial. I'm not going to unfoil it. So you should look at it and go, oh, wait a minute. I could maybe take a 10 out of there. And an x. They both have x in common. I'll take a 10 and an x out. Greatest common factor again. What am I left with? 2x minus 3. All right? So again, set this equal to 0. Set it on either side. Split it up. This could equal 0. When could this equal 0? Divide by 10. What's 0 divided by 10? Put it in your calculator if you're not sure, but you're going to get 0. 0 is a solution. 0 is a number. It's a legit number. Or, over here, when is this equal to 0? I'm going to add 3 and divide by 2. So I get x equals 3 halves. Or if you want to change it to 1.5, there's my 2 solutions again. All right, so I did number 3. There's number 4. You're going to do number 4, A and B on your own. And again, that's part of all this you're going to turn in. You're going to turn in number 3 and also number 4. Similar. All right, moving on, number 5. So we said introduce the quadratic formula. Well, there it is. Just ignore it for a minute. This looks a little scary. Let's come over here and we'll do one more factoring. Solve this by factoring. All right, so I want to factor this. Multiplying gives me 40 and adds up to 3. Now 40's got a lot of factors. Maybe 10 times 4. I don't think 10 and 4 is going to work. 8 and 5. I'm going to go with 8 and 5. I think 8 times 5 is going to work for me. 8 times 5 is 40. And 8 take away 5, right? If I had negative 8, positive 5, I would get negative 3. You could check it. Take the outer and inner and you'll see you get negative 3. So this is working. I split it up. I get x minus 8 equals 0. I'm going to add 8. So one of the solutions is 8. What am I going to get over here? Take away 5, negative 5. That's a nice easy problem. So now I'm going to introduce this formula. It's got a bunch of letters in it, A, B, C, but it's once you get used to it, you're going to like it. Most students really like the quadratic formula. So what does it say? X is equal to negative b plus or minus. What's that all about? Remember there's 2 answers, plus and minus. That's how I get my 2 answers. The square root b squared minus 4ac all over 2a. All right. What is a, b, and c? Well, you might remember this. The number in front of x squared, which is a 1 right now, that's a. A is 1. B is, be careful, negative 3. And what is C? C is negative 40. There's my A, there's my B, there's my C. I'm going to put those numbers into this formula. X is equal to negative B. What is B? Negative 3. I got this plus minus the square root. B squared, negative 3. Be careful here, square it. Put it in parentheses. Minus 4 times A times C. The square root, running into that, sorry. All over 2 times A. What is A? 1. So you see, I just plugged A in, I plugged B in, I plugged C in. Plug and chug, we call this. Ready? What's negative 3? You don't need a calculator for that. That's positive 3. Plus or minus. Most of the work is underneath this radical. You know, down here you just get 2. 2 times 1 is 2. Negative 3 squared, be careful. Negative 3 times negative 3 is positive 9. I guess so many students get that wrong. What's 4 times 1 is 4 times 40. That's 160. But you see there's a negative there and a negative there? That's going to turn into positive 160. A negative and a negative give you a positive. All right. So 9 plus 169 is 169. Now, you might recognize that, or maybe you don't. That's a perfect number. Perfect number. That, if you put that in your calculator and say, hey, calculator, what's the square root of 169? It's going to say 13. So 3 plus or minus 13 all over 2. Now, I guess some students stop here. They don't know what to do. Well, look, remember, there's two answers. What is 3 plus 13 divided by 2? And what is 3 minus 13 divided by 2? Well, 3 plus 13 is 16. What is 16 halves? 8. What's 3 take away 13? Negative 10. Divide that by 2. What do you get? Negative 5. So here's my two answers, 8 and negative 5. Now, some of you might be looking and going, wait a second. Those are the same answers we got over here. What's the same problem? I better get the same answers, okay? So I am getting the same answers. Now, also some of you are probably going, well, this was a whole lot easier. Well, yeah, but sometimes it's really tough to unfoil, and we're going to run into problems in the book pretty soon. They don't unfoil, okay? So I know this was, the first part was pretty easy, and then you just follow, plug all the numbers in. So you're going to factor this one over here. I'll help you out. A is 1, B is 2, C is negative 24. You're going to plug it into the formula and kind of repeat the same process I did. Hopefully you get the same answer for part A and part B. All right, that was the quadratic formula. One last thing. Not all quadratics will work out perfect. What does that mean? Well, look, 169 was perfect. When you do this problem, you're going to get a perfect number too. What are the perfect numbers? Well, 1 is perfect. 4 is perfect. Why? Because that turns into 2. 9 is perfect. Why? Square root of 9 is 3. 16 is a perfect number. You should know these. What's the next one after that? Think about it. 5 times 5. 25 is perfect. What's the next one? 36. That would be 6. What's the next perfect number? 49. What's the next one? 64. What's the next one? 9 times 9, 81. What's the next one? 100. There's no end to this, but we got enough there to start with. All right, so when I see a perfect number, I'm going to cross it out and say, you know what, that turns into 3. Or cross this one out, that turns into 4. It's no longer a radical. This is going to turn into 5, so on and so forth, okay? So it says simplify these radicals. Now you did this. We did it a long time ago, though. Right after we got out back in March, we assigned this. So some of you are probably a little hazy on this. So it says simplify the radicals. 27, you see 27 is not perfect. It's in between these two. Don't put it in your calculator. You're doing it wrong if you do that. You say to yourself, wait, what goes into 27? How can I break it up? 9 goes into it. How many times? 3 times. So what are you going to do with that? You're going to say that's 9 times 3, right? Get it? 9 times 3 is 27. But wait a minute. Remember I said we're going to cross that out? Cross it out and say, wait a minute, that just turns into 3. What about this? That just stays there. So what is the square root of 27? It's 3 radical 3. That's what you got to get good at. Okay, we're going to do a few more. 32. This is tough, 32, because some people might pick 4. 4 does go into 32. If you pick 4, you're going to have to work hard because you're going to have to do it twice. I'm going to pick a better number. 16 goes into 32. You want to pick the largest number. 16 times 2. 32 is 16 times 2. This is perfect. Maybe instead of crossing it out, I'll circle it. I'll circle it. What is that going to turn into? 4. What is that? That is not perfect. That's irrational. If you go back to lesson 2, that's an irrational number. You just got to leave it there. Can't do anything with it. All right. 75. Which one of these perfect numbers goes into 75? Hopefully you say 25 does. 25. 25 goes in there. How many times? 3 times. That's 75. I'm going to circle it. What does that turn into? It turns into normal 5, a rational number. What about that? Just left behind. There's the final answer. 200. What goes into 200? 25 does, but you'd be better picking this because this will go faster. 100 does. 100 times 2. And I'm going to circle that. That's a perfect number. It's going to turn into 10. 10 radical 2. All right. So I just did 4. You're going to do these 4. Don't forget, you're going to hand all this work in. If you can print things out, you already got it. If you can't print it out, you're still going to hand my examples in and then your work in. Okay. And then starting tomorrow, we're going to go back into the textbook. So on the 19th, you're going to be doing Unit 9, Lesson 5. No, sorry, Lesson 6, okay? And you just got to watch the YouTube video. It should be in the stream, should explain it to you, or right there in the assignments. And then after that, you're going to do the homework. So we're going to go back into the textbook and do some new material this week. All right. Stay safe out there.